and welcome to Cherry Pie Math. This video is going to introduce scale in a mathematical sense. We're not talking about the scales that the Justice Lady has in her hand, like, you know, the blindfolded one at the Justice Building. We're talking about scale in comparing two quantities. So before we get started, you do need to be familiar with the concept of unit rates, which is comparing two quantities with one of them being 1. And then you also should know how to draw shapes with a ruler and protractor, because we'll be doing some practice with that. And especially if you have an assignment, you should be familiar with how to use a ruler and a protractor so that you can recreate basic geometric shapes. So let's pretend Lee exists and she's looking at a map. She knows it takes her 30 minutes to travel to a nearby city, and on the map it is 2 inches away. So I'm going to write that down. We know that 2 inches translates to about 30 minutes to travel. A different city that she wants to travel to is about 7 inches away from where she is now. How much time can she predict it will take her to travel to this new city? So we have a couple of options here. I'm going to do one way, and if you think of this a different way, you are welcome to do it the other way. The nice thing about mathematics is there are a couple of ways to do it. Sometimes I like to say there's no right way, but there are wrong ways. So as long as you get to the right answer, like, who really cares? So I'm going to do it this way. I know that 2 inches takes 30 minutes. And because my brain likes to have these unit rates in mind, I'm going to translate it to 1 unit for one of them. And the easiest way to make one side into 1 unit is the inches. So I'm going to say that's 1 inch. And because I divided that by 2, it's going to be 15 minutes. This is a common thing I'll see students do sometimes if they're not just thinking clearly. Is they'll say, oh, I went down 1, so that means this is 29 minutes. Obviously, that's wrong. If you're going to travel 1 mile instead of 2 miles, you're not only going to decrease your time by 1 minute, right? You want to divide it because they're increasing and decreasing at the same rate, and rate is multiplicative. So we know that 1 inch is 15 minutes, so that means that 7 inches would just be, again, we're doing multiplication because ratios are multiplicative. So 1 times 7 is 7, so I have to do the same to the other side. 15 times 7 is 105, so it would take us 105 minutes, or if I was going to change it to hours and minutes, it would be 1 hour and 45 minutes. And hopefully this one isn't too far out there because this is something we're all familiar with. If we're going double the distance, it takes double the time, right? So that kind of introduces us to the idea of scale. And when I was looking up and preparing for this video, I saw this phrase and I really liked it. It was called the ratio of representation. And the reason I like that so much is because scale is used to kind of size stuff down or size stuff up. I'm going to write that under why it's important to size up or size down, keeping the same proportion. There we go. Okay. So the ratio of representation then is just saying we're keeping the same ratio no matter how we're representing it. And I'll write that too so that it's more in layman's terms. So keeping the same ratio in the image, or actually in the quantity, we'll say, because sometimes it's not in terms of the image, although we are going to be mostly doing this with images. So we're keeping the same ratio in the quantity no matter the size. So I could have like a really big version or I could have a really small version, but I'm going to have the same ratio of the quantity. I'm still going to have the same picture. So if I started with a square, I'm not going to end up with a rectangle, for example. So we see scale all the time in real life. The most common one that you're going to see is in a map. Because when you look at a map, obviously, like I have this picture of Los Angeles here. You didn't just fit all of Los Angeles onto this paper, right? You needed to have a way to show this is the distance in real life, but this is how I'm going to show it on paper. And you'll usually see something like this in the corner, where it's saying every time this distance appears, so like here, for example, that's going to be 20 kilometers. And so you can repeat that as many times as you need. So for example, if I was to draw a line from Compton to Huntington Beach, that's like I don't know, 1.5 of those, right? So I know that this is 20 kilometers, so this would be 10 kilometers. And so overall is maybe like 30 kilometers, right? That's guesstimating. And you can be more exact, but it does help you give like an idea of it. It also helps to just show like in comparing things. So like we have the tallest buildings to scale here. You'll also see it with blueprints because you're not going to build, you know, the whole house to show someone what it's going to look like. You're going to draw the pictures of it first, and then they can decide if they like that. And so blueprints are another way that we see scale because it's just fitting onto a piece of paper. You'll also see it often with artwork. This here is called a maquette. It's like a clay version or a smaller practice version of like a really big statue. So this is an early maquette of the Statue of Liberty. Obviously, it's different because it's like a draft and kind of like a sketch is to a final painting. And there's going to be like artistic changes between that and the final product. But it does give you an idea of the scale and about how big the head is going to be in comparison to the body. And it shows, and it's really cool to see like that the scale stays the same, right? This head, let's say, I don't know, it's like 2 centimeters in real life, then it's not going to be a 2 centimeter head, right? You're going to multiply it by however bigger you're going to make the final statue. So we're going to practice it here. So let's say we have a triangle. I'm going to go ahead and make this triangle here. So I'm going to copy this length here. And we know that, oh, it's like slightly off. Oh, that's going to bother me. Ugh. Let me just, oh my goodness. You know, I practice these sometimes and then it just bothers me that it doesn't listen to my instructions. There we go. Okay, that's close enough. Basically. So this is the original thing. We call this the pre-image. And we are going to try to make this 1/4 of that size. When you see the word scale factor, the scale factor is like the ratio that you're going to multiply the lengths by to make your new image. So if I bring this over here, I'm going to measure it, and it's going to be 3 inches. It's supposed to be 3 inches. We'll just scooch that up. Well, it's fine. So that would mean that the new image is going to be 1/4 of that, and 1/4 of 3 is 3/4. So if I was to make this here, that would be how long my new triangle is going to be on the bottom. I took my original length and I multiplied it by 1/4 to get my new thing. So I'm going to see if I can tap it. There we go. I'm going to move that down here. Okay, perfect. So that takes care of the bottom. I do need to do this twice more. But I am limited in this format because I don't know what the angle is going to be. So I'm going to use my handy dandy protractor. I'm going to take my original thing here. So there's my base. I'm going to make, I'm so happy that I can make these into lines. Okay. So I made a very pretty angle here. I'm going to move it over here and find out what the angle is. And it's about 54. We're going to round it up to 54. So we'll say that's 54 over here, 54 degrees. And we'll check on the other one as well. So let me move this down here. There we go. Okay. And then I'll do it one more time on the other side. So I'm going to draw my base. I'm going to just double check. It should be 54 as well. It looks about that much, but we'll just double check it over here. And yep, looks about 54. Okay, because remember we're going this way and it ended up being around 54 right there. There we go. Okay, so let's move this angle over here as well. And there we go. That's actually going to be that triangle that you see at the bottom there. I'm going to zoom in so you can see it better. This is going to be my 1/4 image there. So I took every single length, and if you measured like those diagonal pieces, it would be 1/4 of the original size as well. And this is would be what I call my image. So this one here is called the pre-image. It's what we start with. And this is called my image. Okay, and that's really all it is. You just have to make sure that each of your lengths are a quarter in this case, because that was my scale factor, is a quarter of what I started with. If the scale factor was 2, I would have multiplied everything by 2. So what info do we need then? So like, what if I told you to make a 10 by 15 rectangle smaller? What's the problem there? You wouldn't know how small to make it, right? You need to have a scale factor. You need a scale factor. You need to know how small to make it. Otherwise, you wouldn't know when to stop, right? And the scale factor will tell you what to multiply one of the sides by so that you can multiply all of the sides by the same thing. So here's a common misconception that I wanted to go over. So let's say this is my pre-image over here. Here's my rectangle. It's 6 inches squared in terms of the area. And there's 2 rectangles it could possibly be for its image. So here's rectangle number 1. And then, so rectangle number 1's up there, rectangle number 2 is down here. Which one is the right one and which one's the wrong one? So I'll give you just a second to look at it. Pause the video and see which one is 1/2 the size, or 1/2 image. Which one has a scale factor of 1/2? Okay. If you said image 2, you would be wrong. This is one of the common things that I'll see happen is students will see, oh, that's a 6. I know that it has to be 1/2, so that means the area has to be 3. But that's wrong. When we're applying the scale factors, we're not applying the scale factor to the area. We're applying a scale factor to the sides. So when we do 1/2 of the sides, we actually end up with 1/4 of the original area because we're multiplying both sides by 1/2. But then when we find the area of a rectangle, we're actually doing 1/2 times 1/2, which comes out to be 1/4. So just be a little bit careful about that. Make sure that you're multiplying the sides by your scale factor and not the area by your scale factor. What about the angles though? Angles are super cool because angles stay the same. If the angles change, we wouldn't end up with the same picture that we started with, right? Like if I started with a rectangle and I said, oh, I'm going to have different I'm going to have different angles now, and end up with like a trapezoid or something, which is not the same image. So angles have to stay the same in order to preserve the integrity of the picture. So some just things about wording, you'll see a different couple ways that you'll be applying scale to. So if you see apply a scale factor of x, where x is a number, or you scale up x, you multiply just by whatever it says x is. So like if it we had scale factor of 1/4, you would multiply by 1/4. However, if it says shrink by a factor of x, so for example, if it says like shrink by a factor of 2, for example, this really means to multiply by 1/2. And the reason for this is because when we say shrink, we obviously intuitively know it has to be smaller, so we can't multiply by 2. 2 would make it bigger. So when we say shrink by a factor of x, it means multiply by 1/x. This is just going to make it a fraction instead. So you just have to make the x into a fraction. So pause the video, write those down so that you know that when you multiply by x and when you multiply by 1/x. So some things to remember. Scale factors are always multiplicative. You are never going to add or subtract when you have a scale factor. It just will screw the whole thing out. Angles will stay the same. It's the side lengths that are affected. And that's a really important principle that you'll use later in geometry as well. Shrink means that you have to make a fraction, and it's just easier to do it with straight sides. So if you have to do an assignment where it's like design your own picture and then make a scale version of it, it's just easier to do if the lines are straight. Not impossible. Obviously, artists do it all the time, but it's just a little bit easier if you have like straight lines to deal with. Okay, I hope that helps, and good luck.